let's explore finding the domain of a function from its formula. Let's begin with a formula. We want to define a function out of this formula. We will use the rule encoded in the formula to come up with the rule for our function. The function will take in a number, and it will output that number raised to the fourth power plus 2. So here's the rule for our function. Another thing we need before we can proceed is the domain of our function. For this, we will use the following. So which real numbers, when plugged into the formula, give defined real numbers? This is what we need. Let's discuss this some more. I recommend using this approach. How do we determine the domain? I recommend finding the numbers that are not in the domain. Which numbers are excluded from the domain? For a real number x, this can happen in one of two ways. The first is that it causes division by 0 somewhere in our formula. The second is that it leads to taking a square root that is not defined as a real number. For example, the square root of minus 1. It's defined as a complex number, but not as a real number, which is what we need. Some radical of even index, like the square root, the fourth root, the sixth root, etc. A problem arises when you have a radical of even index with a negative radicand. Again, the radicand is what's inside the radical. So once you find the values of x for which the first case happens, and you find the values of x for which the second case happens, you exclude exactly these numbers. Let's do a number of examples. Let's use this approach to determine the domains. Let's do these 4 examples. In each example, we will determine the domain using this approach. In this first formula, x to the 4 plus 2, there are no denominators. So right away, we know that there are no numbers to exclude because of the first case, division by 0. And we look at the formula, we also see that there are no radicals. So there are, of course, no numbers leading to taking an even index root of a negative number. So right away we know that there are no numbers to exclude, so the domain is all real numbers. Written in interval notation, it looks like that. The second formula, x minus 2 over x squared minus 4. This does have a denominator in it. So to find the values of x that make the denominator 0, simply set the denominator as it is equal to 0 and solve for x. So we get two numbers, plus 2 and minus 2. So we'll have to exclude those. And we look at this formula and see that there are no radicals, so right away there are no numbers to exclude from case 2. So we need to exclude these. So in interval notation, it is written as the union of these three intervals. How about this next one? Here's one with a radical in it. So this, first of all, has no denominators, nothing to exclude from case 1. And then for case 2, it does have an even index radical, right? We're taking the square root of 6x plus 8. So we want to know for which values of x is the radicand negative, strictly less than 0. We solve this inequality, and we get x less than negative 4/3. So we have to exclude these numbers from our domain. So our domain is everything else. It includes negative 4/3 and all numbers greater than it. What about this last example? Here is a formula that has both the denominator and a radical of even index in it. Let's see what happens. First, case 1. Set the denominator equal to 0. Solve for the variable, which here is t. Doesn't have to always be x. You get t equals positive 23. So we know we'll exclude that. Now over here, we're taking a square root. So when is this radicand negative? It's negative when t is less than minus 5. So we also have to exclude that. Just like in the last example, we have to exclude a whole segment. So here, I encourage you to draw this out. Let's think about what we are excluding in red. Exclude what's in red. So what we include is everything else. Minus 5 up to 23, but not including 23, and then everything greater than 23.